Okay, we continue with gear ratio item. We have this three graph: power required to drive vehicle, power available to drive vehicle. Curve show balance between power available and power required. So this one, we have power available and power required. If the power available is more than the power required, then you will have the excess power for acceleration, to accelerate. Accelerate. Okay. But first of all, the tractive resistance, for you to move, we have to be more than the tractive resistance, and sometimes we call it as total resistance. This resistance include air resistance, rolling resistance, and gradient resistance before the car is moved. So air resistance due to the movement of the vehicle through the air, and rolling resistance due to friction between the tire and the road, largely influenced by the type of road surface, and type of tire tread that you use. And the third one is the gradient resistance. This one is increases as the steepness of the inclined hill act as the vehicle motion. So if you are climbing a hill, naik bukit, so this one will be a very significant resistance. Figure or graph A indicates the power needed to propel, the graph just now, and then a given vehicle increase with a cube of speed. So this power means that if you want to have, if the speed is double, and the power required is 8 times as great, sebab dia cube, increase with the cube of the speed. So in this example, the power is 150 kilowatt is needed to drive the vehicle at 200 km per hour. Okay, so you have seen 100 km, 100 kilowatt, 150 kilowatt to power for the acceleration or the vehicle speed as 200 km per hour. So the output and the engine fitted to this vehicle is shown in this under gear and over gear graph. Under gear and over gear. The one in the middle one, the B one, is we consider as the optimum, and if it is less than this, we will call as under gear. More than this will be over gear, right? So this power curve shows the engine produce a peak power brake at 150 kilowatt at 5000 revision per minute RPM. So we have seen this in the previous graph. So if the maximum road speed is to be as high as possible, if you want to have a very high road speed, so the gear ratio of this vehicle must be set so that the peak of the power available curve occurs at a road speed of 200 km per hour. So this curve, the peak of the curve must be at 200 km per hour. So in this vehicle, this is for this model example. And in this case, the overall gear ratio times the gearbox ratio times the final drive ratio, and must ensure that the engine speed of 5000 RPM drive the vehicle at 200 km per hour. Once the relative position of the curve have been decided, so we decide this first, and then it is then possible to examine the general performance of with respect to the acceleration. So the vertical difference between two curves, this power available curve with the power required curve, the vertical difference between the curve will be the available for acceleration. So this can be plotted as a separate curve to show the speed at which maximum acceleration is achieved. We can know what kind of acceleration the vehicle can do. And assuming friction is neglected, it must be appreciated that the gearing system neither increases or decreases power. That is, the power output of the transmission system is similar to the engine brake power, irrespective of the gear ratio. Okay, so this difference is actually, if you plot a graph, you can have this graph, so they will call as power available for acceleration. This one is optimal. In this view, in view of this, a change of gear ratio of the vehicle shown in curve figure just now will cause the peak to move horizontal. So if you change the gear ratio, the peak can be moved horizontal, whether to the A or to B. Lowering the ratio, if you lower the ratio, curve A move power available to the left. This curve B will move to curve A if you lower the ratio. And if you raise the ratio, or rising ratio, the curve B will move to curve C or to go to the right. So the PB, PA, PC, so the P is moving horizontally. And these two conditions called under gear or over gear respectively. So to the left we call under gear, to the right we call over gear. So in both conditions, the maximum possible speed is reduced, but this is not the prime consideration. Even though maximum speed is reduced, but dia boleh ada certain other advantages. When compared with the optimum gearing needed to obtain the ideal maximum speed, the advantages of these two gearing condition is, for under gear, you have the advantages of more power for acceleration, because the vertical difference here is bigger compared to the C1. So the vehicle is more lively. And flexible top gear performance, so less gear changing is necessary when the vehicle encounters high tractive resistance. So usually for sport car, they will have this under gear punya design. But for over gear, they also have their own advantage. Lower engine speed for a given road speed, so it will be better economy, lower engine noise level, and also less engine wear. So for passenger car, a big passenger car which don't need to go for speed, I think they will use this one, better economy and lower noise. The advantages and of undergearing can be used to obtain the advantages of overgearing, vice versa. And a comparison of two conditions show the undergearing is more suitable for average car, and the undergearing extend about 10 to 20% in common, and this means the engine power peak occurs at 10 to 20% before the maximum possible vehicle speed is reached. For maximum traction, once the designer had set the overall top speed ratio, so they will decide the first gear ratio, and this gear used when moving off and also needed for maximum tractive effort is required so as to enable the vehicle to climb a very steep hills. So the top gear, then decide the bottom gear, and then the tractive effort is based on engine torque. So maximum tractive effort is particular gear occurs and when the engine is developing, it maximum torque. So based on engine torque, we can have the maximum torque or maximum tractive effort.